this session. Now we will solve one problem. Okay, the same problem. This is the same problem which we have seen just now, Ehrenfest theorem, using Schrödinger equation. But now we are going to do on the other way around. We are not going to use Schrödinger equation. We are going to use equations of motion in quantum mechanics, probably which we will study in the next unit. I have written in advance. Okay, we are going to study this equation in the next session in terms of pictures. So in the next unit we will be studying 3 pictures: Schrödinger picture, Heisenberg picture, interaction picture. Okay, there we are going to derive some equation of motion, and you will obtain exactly this type of equation. Okay, so just remember this equation alone. So this is the equation of motion in quantum mechanics. So you remember this type of equation alone. Okay, so this bracket is known as a commutative bracket. This bracket. So a comma b will give you ab minus ba, probably which we have studied already in mathematical physics. And of course we know the expression value. Okay, this is the way it is. Now we know that Hamiltonian H equals kinetic energy plus potential energy, sum of kinetic energy and potential energy. Any operator A can be replaced with px. Where we can replace, doesn't matter. So dpx by dt equals 1 by Ih cross. A is a general operator. We are going to have px, though px is the main operator which we are going to study. So px comma h will give you dpx by dt. Px stands for component of momentum in the x direction. Suppose this term doesn't depend on time t explicitly, then we can say that we can drop it out. Okay, so we can write this equation. In a doubt, we can write this equation. So p comma x, you just take px comma x, commutative bracket of px comma h. Your px is, I have written like this. Hamiltonian, I have written like this. Correct? Now px comma px squared by 2m plus bx. Correct? So you have a comma b. But px here px is there. Okay, x comma p, for example x comma p, they will not commute with each other. So that means simultaneously you can't measure. Suppose if you have position and momentum in commutation bracket, they will not commute with each other. It means you can't measure simultaneously x and p. Okay, which you have studied earlier. This is called uncertainty principle. Okay, x comma p. But here px and here also px is there. Okay, both will commute with each other. So when you commute with each other, answer will be 0. So this term answer will be 0. Only this term alone will exist. So you will have px comma bx. Is it clear? Okay. Now, so px will be, already we know that px equal to minus ih cross d by dx. We know already. So last slide, px comma h equal to px comma bx. ab equals ab minus ba, you should know. So this is the commutation relation. Instead of px, you can substitute minus ih cross d by dx, vx psi of x. So operating on both sides by psi of x. This term operates on psi. Okay, this term operates on psi. We can write operator operating on psi will give you a comma b. A comma e equals ab minus ba. So ab minus ba. You can write like this. Correct? ab minus, already one minus is there, so it will become plus ba. Is it okay? Now you can see v of x, psi of x, differentiate with respect to x. Correct? So keeping this as constant, you have to differentiate this. Keeping this as constant, you have to differentiate this. So we have differentiated exactly like this. Is it clear? dvx we have differentiated keeping this as constant, minus keeping this as constant, you have differentiated this. This last term and this term will get cancelled. You have this term alone, first term alone. So this term becomes this term, minus ih cross dvx by dx I of x. Is it okay? Is it clear? Now what is this term? This term already we have done p of x, px. okay, component of momentum, okay, P of, this is V of x, this is Px, this is V of x, psi x equal to this term, okay, this term you know already from there, from the first one, so we can write dpx by dt, okay, which is equal to 1 by IH cross is there, we have found out this one, correct, we have found out this one, so 1 divided by IH cross multiplied by minus IH cross dv by dx, so IH cross IH get cancel, you have minus dvx by dx, this side you have dpx by dt, the expectation of the momentum is nothing but the expectation value of the gradient, so you have the expectation value, okay, gradient, potential energy, potential gradient, okay, so this is proved. So this is on the other way around, we have not used the Schrödinger time dependent equation, rather we have used only the equations of motion in quantum mechanics, okay, so that is the end of this session, okay, so thank you students, we will see in the next session, bye.